and go through a little example of relating the angular motion of the Earth as it spins on its axis to the linear motion at some point on the surface of the Earth. So the Earth is going to rotate once on its axis with an angular speed omega. I actually don't want to worry about the sign of that right now. So I'm just going to put that in absolute values. So I'm going to just calculate the magnitude of the angular speed. And we know the Earth is going to spin once, so that's 2 pi radians every day, so 24 hours. It's not necessarily the most useful set of units for time, so I'm going to change that. So multiplying by 1 to change units, 1 hour is 60 minutes, and 1 minute is 60 seconds. So that's going to give me hour cancel hour, minute cancels minute, and carry out all that. 7.27 times 10 to the minus 5 radians per second. And I want to measure the angle in radians because we want to use omega to relate the distance away from the rotation axis to a linear velocity. And to do that and not have a conversion factor, we need to have the angle in radians to begin with. Because it is radians that are going to relate things like radius to circumference of a circle. Radians are unique amongst the units that we use in a physics class. It's dimensionless. You think of radians as coming about from the radius, from the relation of circumference to diameter for a circle. Those are both lengths, and that cancels out. So radians, they're dimensionless. You can bring in a radian whenever you want. You can make radian go away whenever you want. All right, so given omega, if we're at a particular location on Earth, let's say at the equator, so we're the greatest distance away from the rotation axis that we can have, what is our linear speed? So our rolling without slipping condition, we're saying that the speed, linear speed that we have going through a complete and continuous angular rotation, that's going to be r omega. And for Earth, that radius 6.37 times 10 to the 6th meters. And omega we just calculated 7.27 times 10 to the minus 5 radians per second. And that's going to give me a linear speed 4.63 times 10 to the 2 meters per second. And I just dropped the radians because I can, because it's dimensionless. So at Earth's equator, you are moving close to a half kilometer per second. And if you would go all the way up to the rotation axis, so there, your distance from the rotation axis is 0, your linear speed would be 0. So people, when they think about launching things into orbit, you want to do that from a location where you already have as much speed as possible. So launch locations tend to be close to the equator. In the United States, we launch from Florida, not from Minnesota. Europeans will launch from the north coast of South America as opposed to launching from Europe.